Okay, so first thing I'll do here is check if the dial pointer lines up with the how it should. Let me just check with my other tuner. Let's just switch to my digital tuner here. Okay, so that station should be 99.9. Oh, we have it over there, which is... See, this is 100, this is 99. So we receive it over there. Let me turn down the volume a bit. We receive it over there, and it should be over here. So, yeah, it is quite off. Let's see if it is symmetric. I have another one. Let's switch to the other tuner again. So that should be 101.4. Let's switch to this one again. I can't even find it. Huh? Where is it? It's in the other direction, obviously. There we have it, and it should be 101.4. Okay, I was incorrect. So the 99.9 should be over there, and it's, okay. So the 101.4 should be, this is 100, 101, should be over there somewhere, and it is actually over there. So it's 1.5 megahertz out. Let me see if I can find some on this side of the band. So this is the first one I pick up. Classical music should be around 90. Let's see if I can find it on my digital tuner. Yeah, here we have it. It's at 89.9. And on the tube Philips tuner, we have it at... We have it over there, so it should be there, and we have it over there, so it's also 1.5 megahertz out. So that seems like it's a bit linear, as it's everywhere out at the same amount. So you'd say, yeah, well, why don't you just then shift the pointer? That would be the easiest solution. But the problem with that is the pointer is quite well centered. So see here, it is like 1 centimeter. The maximum is 1 centimeter to the right at the end, and here on that side, it's also quite well centered. So if I'm going to shift the pointer, I need to shift it like to the right, and then I'll hit here this side. So that won't be an option. Now, I did notice something else. So remember in the beginning when I was working on the tuner that this is here the FM tuner. It's an inductive based tuner. It's not a capacitive tuner. And remember that this was completely stuck, and I needed to get this unstuck and everything. You can also hear clearly that this is the tuner. See. Yeah, and I also noticed that some of these wires here, which keep the coils in place, that they were bent a bit. Maybe because because it was stuck, and maybe because of the force being placed on this part. So I'm just gonna try and bend maybe these wires a bit, move the coils a bit upwards or downwards, and see what the result is. Maybe that's the best way to get this more or less correctly again. Okay, so this is the station that should be at 99.9. Let me now put the dial on 99.9. And now let's see if we need to move this up or down. Yeah, okay. Here it is. So it needs to move slightly up. See? So I guess that means that we should bend these wires a bit, if that's even possible. Oh, it's almost there. That's even a bit too much. Or is it? No, it's fine. It's fine. Okay, that would have been the easiest RF alignment I've ever done. And also the safest, if you just do it safely, that you don't detach the wires from the cores, but I wouldn't suggest fiddling too much with it, but yeah. It's maybe on a Philips safer than using the coils or trying to adjust the coils. Yeah, so see here, this is now the 99.9 station, and it's spot on 100. I guess that's fine. So let's find the 101.4. There it is, I guess. So that's half-wave between 101 and 102. That's perfect. Let's see if that was really the one. Yeah. So this is 101.4. That's perfect. And let's find the one here on 89.9. The classical station. Where is it? Yeah, perfect. Just before 90. Okay, so the FM alignment. As you see, I already did a bit of preparation, but let's first see in the service manual what they ask us to do. So this is the instructions for the FM alignment, and the first thing they say is, so the alignment is done using an unmodulated signal. So they ask us not to put any modulation on the signal, and then they say there is a voltmeter. Again, they speak about the diode voltmeter. Connected across R29. I'm going to show you that resistor in a second on the schematic. Via a resistor of 100 kilo ohms, and adjust the signal strength in such a way that the maximum indication on the voltmeter is 3 volts. So let me show you on the schematic what they mean. So here we have the detector. See, this is the tube, the detector tube. This is the EABC80. This resistor that they are talking about, R29, that's this guy over here. So what they are basically saying is that we should measure across R29 with a 100 kilo ohm resistor in series. So that basically means that we're measuring across the capacitor here as well. So the electrolytic, which is the capacitor for the FM detector. So what we are doing here is we're measuring the signal strength, because as you see, this line over here, it's also going to the tuning eye. Yeah, maybe it's just outside the screen. Here is the magic eye, and here you have this signal is basically an indication of the signal strength. So what we are measuring here is the signal strength of the station that we're picking up, and we're measuring that across this capacitor or this resistor, doesn't really matter. Yeah, in the FM detector. Now what is really nice is that they actually give us an indication here in the service manual that the signal strength, that we should apply a signal, but that it shouldn't be more than, so the signal strength that we measure over here shouldn't be more than 3 volts. So I haven't seen this a lot yet in service instructions or alignment instructions of radios, that they actually say, and they give you a way to measure the signal strength, and that they say what the threshold should be so that you don't go too high with the signal strength that you're applying. So let's try to set that up. Then they also say, when not mentioned, all the signals should be applied via the antenna connection. But here, yeah, this is not applicable, because yeah, we'll inject the signal via the pins that are mentioned over here. But let's first try to set this up. So as you see here, I have the voltmeter. Let me turn it on. I have the voltmeter connected here between ground, and on the other side here it's going to a 100k resistor which is connected over there. And there we have the detector electrolytic capacitor. And there R29 is all the way in the back. You can't really see it, but this is the point where we are measuring the voltage, which should be the signal strength. So when we are applying our signal, we shouldn't go above 3 volts. And that's not a lot. Let me show you. Okay, so I have the tuner turned on now, and I have, yeah, it's just the FM antenna connected. So we're just going to tune into a station. See, we're here at, okay, it's minus, it's a negative voltage, but we are here at 9 volts. 23. See, this is a station which is coming in really well, and that's almost 24 volts. Here we are in between stations. See, but you see, as soon as we tune into a station, we are easily above 10 volts. See, 21. That's a really local station. That is just only a couple of kilometers from where I am. But see, so 3 volts is not a lot, because a normal station is coming in easily in good reception above 20 volts. So let me just disconnect the FM antenna. Okay, and now let's see where we should apply our signal from the signal generator. So the first thing here they tell us is to put the dial pointer on 89.5 megahertz. Now that doesn't matter that much because this is an alignment of the IF, but let's just do it anyway. I'm just gonna put it on 89.5 like this, more or less. That doesn't really matter that much. And then we're gonna apply a 10.7 megahertz signal, which is the IF frequency, via a 1.2K resistor to the grid of B4. Now B4 is the second EF89, and that's that guy over there. So I have the signal going in over here via a 1.2K resistor, and then I'm measuring with the voltmeter over there the signal strength. So let's turn on the signal generator and let's see what we get here. Now my signal generator, I guess the signal will be quite high because it's the last stage before the EABC80. So it's the last EF89, so the signal will have to be rather relatively high, so I don't have any attenuation at all. I have the signal generator set to 10.7 megahertz. I don't have modulation, and I have it at the minimum that the signal generator can do, which is 4 millivolts peak to peak. I guess that's the minimum that I can do. Yes indeed. So we're just gonna start at the minimum, see what we get, and we're gonna increase the amplitude until we get 3 volts as they measure, as they mention in the manual. Okay, turning on the output of the signal generator now. And as you see, that doesn't make a lot of difference. Maybe if I enable the modulation, will I be able to hear something? No. Nothing at all. No, that's way too low. Just disable the modulation again, and now let's go up. I'm gonna go to 10 millivolts peak to peak. Yeah, see, it's gonna need to be increased drastically. 20, 30, 40, 50. Let's go straight to 100. And we're at 600 millivolts here, and if I enable the modulation, yeah, I can start to hear the signal, but it's very silent. I have to turn up the amplifier all the way to hear something, so it looks like we still got a way to go. Let's maybe immediately jump to 200 millivolt peak to peak on my signal generator and see what we get here. 1.2 volts. Okay, 300 millivolts, 1.8, 400 millivolts, 2.5, 500 millivolts, And we're above the 3 volts now. Okay. Let's maybe go down to 450. That's too low. I'm now at 470, 480. Voila, there we have it. Exactly 3 volts. And if I turn up turn on the modulation, yeah, it's clearly there. Okay, all right. Now, next step. Well, this is basically done. Well, basically nothing is done. We just have to set up. We have the signal applied. We have the correct signal strength. And now it tells us to adjust S38 for a maximum. Now, I don't know if I'm going to do the entire alignment, but I am going to do the first step here. And you'll see why in a minute. But let's first here align the S38 for a maximum. And to do that, as I already said previously, all the adjustments here on the tuner are on the top. So let me just shift it around here a bit. So S38 is that guy over there. And I can see it, and let's see if we can do something with it. I'm going to be very careful. I hope it doesn't break. No, it's really difficult and really stuck. I need to be very careful with this one. All right, I managed to get it unstuck with some hot air. But still you have to be very careful. See, if I twist it to the right, it goes down. If I twist it to the left, it goes up. So let's see if we can get a maximum here. I'm just being very careful because I really don't want to break this. I'm not gaining that much anymore. Maybe I need to reduce my signal strength now a bit. Yeah, here it's going down again, so let's go back. Okay, that's more or less peaked. Next step. That is, they say we should adjust S40 for a minimum. Now S40, what is S40? S40 we are basically adjusting the detector or adjusting the symmetry of the detector, and here they say to align S40 you have to connect two resistors of 220 kilo ohms 1% in series across C67. Again, here the detector capacitor that we have over here, which I replaced, there we're gonna measure the to see if the detector is aligned, and we should connect two resistors in series, two 220k resistors in series together, and then we'll measure from the middle of these two resistors. See, they say here the voltmeter has to be connected on the cross section between both resistors and the cross section of R21C62. That's that point over there. So what we're basically doing is measuring between here and then between the two resistors that we have connected across C67, and there we should align to have a minimum of voltage between the two. It should basically be zero, because that means that the detector is aligned symmetrically. It is quite important that the two resistors that we use here, the 220 kilo ohm resistors, should be as close together as possible, because we want to measure the symmetry. And if they are quite far apart, then yeah, obviously, yeah, it won't be completely symmetrical. That's why they say here that you should use 220 kilo ohm 1% resistors. So because I like to do things here really exactly how they specify it in the manual. And yeah, there are other ways to align the detector, but I love following the original instructions and following them exactly how they specify it. I actually went to the shop and bought 220 kilo ohm 1% resistors. So then we can exactly do what they say over here. So let me just hook this up and then we'll see what we get. Just out of curiosity, let's check how close they really are. Let's see, this is the first one. 219.8. Not 7.8. Second one. 220.1. Okay. I think we can get a closer one. 220.1 as well. 220 exactly. So the first one, I'm gonna put it to the side. So that was the 220.1, and this one also 220.1. So these resistors, they are nearly damn matched. So we're gonna use these two. Okay, so I have done the setup. I connected here, as you don't see it. Here, the multimeter on this side between the cross section of both resistors. They are across C67, and then I connected the voltmeter on the other with the other lead to the cross section of C62 and R21, and then they tell us to adjust S40 for a minimum. And S40 is this one over here. And you see we have 55 millivolts. Let's see if we can adjust it. It's doing something, but this cord is also will take a lot of wiggling to get it moving. Okay, so this is why you should be careful when adjusting these Phillips cores. Not sure if you can see it, but that's the one of the detector over there, and yeah, the core inside broke. So it's just I'm saying, and all the time, I'm not gonna adjust the FM. I'm not gonna adjust the FM because they are so fragile. But yeah, you see, it broke off. Well, I do only think that the thread of the screw is broken because the radio is still working fine. I only think that the head of the core is broken, so I cannot adjust it anymore right now. We have 104 millivolts at the moment, which is worse than it was, but yeah, I tried fiddling a bit with it to get it lower, but it's not easy, and I think I'm gonna leave it like it is. It does still sound perfectly fine, so I'm gonna leave it. If it really sounds bad, or if I think there is really something wrong with this, or if it sounds off, then I can still replace the core. I do have these types of Phillips cores as a spare, but I'd rather not do it because it's a lot of work. And yeah, so the rest of the FM adjustment, we're not gonna do it because it's basically the same thing, right? It's just adjusting all the cores here of all the IF stages, and the FM is honestly coming through fine. And here the RF, that we can check, but I think when we adjusted the scale or the dial, that was already enough, so I also don't think this needs to be done.
They'll be safe with me. We've all been. I said
Paul Heller au saxo, Gersmans à la contrebasse. J'ai bien sûr choisi pour vous et pour terminer cette émission le morceau qui était chanté, I Think of You, chanson interprétée.
Typique, mais comment...
Weer een ingestudeerd nummertje, dat is al de tweede keer een vrije trap.
Yeah, again football as usual.
Gezet. Nee, balletje breed en dan gaat het eigenlijk van de linkerkant naar de...
But as you can hear, the radio is working perfectly fine now, and it's sounding great, honestly. So I'm just gonna leave the detector as it is, even though it probably isn't completely perfectly spot on, especially now with the core being damaged. It's still working perfectly fine, and I'm gonna leave it like it is. Not gonna bother with the FM anymore. It's working really well. So yeah, that's it for the video. Now the only thing that is left for me is putting everything back together. Stay tuned. If you were still watching, thanks for watching. And guess I'll see you next time. Take care. Bye bye.
Over de zijlijn en Zoetwaregem samen met Miroshi. Tanzania.
Waar hij er nu uitziet en die jongens, dat is eigenlijk wel echt straf. En we hebben jou afgelopen week...